Rajiv.
Hello.
Hello. Good evening.
Okay, see, today we'll do this structure. Actually, I have analyzed this structure in ETAP, but I just want to analyze in StatPro also. So, see the length and width, that is 6 meter. All the sections length and width is 6 meter. And we have total number of stories about 23 story. But from story 1 to 8, we have this shape, square shape. And from story 9 to 14, we have this shape. And from 15 to 19, we have this shape. And after that, 20 to 23, we have to create this shape. And see, we have this column and beam size. Actually, in E tab, there is one options there that is called auto select. So if you have to only give this property in E tab, and it will assign automatically according to size. It will assign automatically on structure. But in StatPro, we have to give a manually. This size is 500 by 500, 550 by 550, and 600 by 600 column. And beam 500 by 300, 550 by 350, and 600 by 400. And the slab thickness about 150 mm thickness. Okay, so let's create this structure. How many floor? 1 to 8. 6 meter length and width, and 3 spacing. Here, 3 portions. So new project, space, in the load, stat file, meters and kilometer. Next, add file, finish. Okay, I want to see this grid in XZ in top view, and the spacing is about 6 meter, and number of steps we need 3. And in Z-axis also we need 6 spacing, and number of step 3. Okay, so from this point to this one, first escape, again click on snap node beam, click here, join, escape node, just join, and snap and node, snap and node, see, this time I am using a grid also, because we have 4 or 5 types of method to create a structure in StatPro. So in last class we have created a structure with run structure geometry. Now I'm creating with grid. So just close this grid, see. And I want to renumber beams here. See, all the beams we have. I have to renumber the node numbers and beam also. Shift N. Just press Shift N for node number 1, 2, 3, 4. So I want to renumber it. So I just select first all the nodes. Go to geometry, renumber node. Yes, with 1 in x-axis and in z-axis, or I will do for all the axes in ascending order. X. Okay, 1, 2, 3, 4, 5, 6. And I also renumber beam. So Shift N for off node numbers and Shift B for beam number 1, 2, 3, 4. So I select all the beam. Again go to geometry and renumber member. Yes. With 1 in ascending order, X. Okay. 1, 2, 3, 4, 5, 6, 10. Shift B. Okay. Now I just select all this structure, then in go to translation repeat in y-axis. I just give the height about suppose 4, give the height of 4 meter, and number of step I need only 8. 1 8. Link step in y-axis, number of step 8, and default step spacing is 4 meter. Then delete bottom beams. It's already selected, so delete. Then say go to front view, select top portion, and right click and go to new view. Okay, done. Now just go to top view and select this side portion, because we need this side portion. We don't need of these 2 beams at this side and 2 beam at this side. So I have left that 2 beam at this side and 2 beam at this side. Now I have selected this one, and then go to translation repeat in y-axis, and spacing is 4. See how many step we need. 9 to 14. 9, 10, 6 step. 4 meter, 6 step. And link step, then okay, done. Then again I just go to top view and select the top portion, front view, select top portion, isometric, right click, new view, then again go to top view, and this time we need this 4 side, so we have to leave 2 beam for all the 4 sided. So I have to select this portion, control press, and this portion, isometric, and see how many steps we need. 15 to 19. 19 means 5 steps we need. Yes, save the project, go to geometry, sorry, yeah, here also we have the translation repeat in y-axis, 4 meter, 5 step, link step. Again go to front view, select top portion, then right click and go to new view. Okay, then see, we need only these 2 portions for top view, and number of step we need for 20 to 23. Just select, go to top view, and I need this side portion, isometric, translation repeat in y-axis, 4 step we need 3, link step, done. Now we need back all the structure, so click on this tab for display whole structure. With these options, click on it, so see, we get the whole structure back. In front view, see, front view, back side, left side, right side, top view, bottom view, and isometric view. And then see, next we have to give a section property. So for section property, go to general and define column beam section property. Go to rectangle, and first we have to give column size as 500 by 500 mm. Rectangle 0.5 by 0.5 means 500 mm. Then material concrete at 550 by 550. 555, 0.55, 0.55, and then 0.6 by 0.6. 5 by 550, yes, 600 mm close. Now we have to assign this three column size. So go to front view and we have to assign manually here. So first I just select this portion. Have options. Okay, just second. Okay. 1. Okay. Then assign. Assign to selected beam is already selected here. So just click on assign.
Is there any option to deselect?
G select.
Deselect.
B
Just I
select.
deselect. Just I selected wrong part. Then
Yes. Yes. Shift press and just click on it. Shift with shift. Deselect. Yes. Shift with shift press and just click again.
actually you selected the beam also.
B.
Then
Yes,
started from
but
first.
yes, but see if I am in front view now, but if you see in 3D, we have the lot of beam I have selected there, full first portion. So that's why I click outside there. Then 550. So 550 is for this. Assign. Then 500 mm. Assign. Save the project. Now next for a beam, and we have three beams, same 5 by 3, 550 by 350. First we create 5 by 3. So in define rectangle, 0.5, 0.3, yes, 3. Add. Then second one is about 550 by 3, 5 and 0.35. Add. Then last one we have 600 by 4, zero point 0.6 by zero point 0.4. Yeah. Add. Then close. Go to front view again, and now we have to select the beam. And then assign. Then next 550 by 350. This then assign. Then 500 by 300. Okay. Assign this method. Go to 3D render view. Okay. Then next assign a plate. So for plate again go to geometry and select all x and z axis, beam parallel to x axis and where it is? Select beam parallel to z axis, all beams in x and z axis for plate, and then click on fill floor grid with plate option. So click on fill floor grid with plate. 145 new plate generated. Then go to general and define thickness. Okay, click on thickness, and the thickness of this plate is 0.150 0.50. Then add, close. And for plate, I just select the plate cursor, select whole plate and assign. Done. We'll see. See all column beams material assign on this structure, plate also assign. See, if you want to change color of any column or plate, just right click here and see we get this option, change entity color. So click on it, see the beam and plate color are same. So I just click here and just give apply. Beam and column. Then go to support, create support, add fixed support. Select the fixed support, go to front view, select this last column points that assign a support. Then go to load and definition, and in load definition we have to define wind first. So go to definition, save project. In definition we have to give, and see one more thing, we have to give a wind load definition considering two parameter in Bangalore, and see we have dead load and live load also, we have this, and there is a different load here in from story 1 to 8 we have to give -2 kilonewton per meter square this dead load, and live load is about -5 kilonewton, and from 9 to 14 we have same load, that is 2 kilonewton per meter square. Live load is 4.5, 4 kilonewton live, 2 kilonewton. Okay, dead load is same on all floor, that -2 kilonewton, but live load is changed, 5 to 4.5, then 4, then 3.5. So we have to specify the range also. We have to specify range in y-axis range. So just go to Stad Pro and first create wind definition. Select wind definition, click on add, and type 1 wind 1, add, close. Select type 1 wind 1, add, and we have to calculate. Then next we select the latest code, that 2010 building classification category. We want to design with category 3rd, and with Bangalore. What is the wind speed in Bangalore? We calculate wind speed in meter per second. Bengaluru, that is 33 meter per second. Bengaluru 33 33 wind speed. And exposure category, so we have three category: urban areas, open field, or open field with water resources. So I give just exposure C for open field. And structure type is building structure. We have building structure or chimney or solid sign or lattice or truss tower. So we select building structure, apply, okay, add, and exposure factor is 1, add, close. Select the exposure factor, assign to view. Okay, then go to load case detail, add wind, wind in X positive direction, copy, Control C, add, Control V, that name here, and negative direction, then Control V again for Z positive, Control V, copy, add, then Control V, negative Z axis, add, close. Select wind X positive side and add a wind factor. Go to wind load and wind in, always assign a wind load in windward face. That is the front face. Okay, so windward face. So in x-axis factor is 1, and also we have to specify height of the structure in y-axis only. So for y-axis, I just go to any side view, select measure tool from node to node, 88 point, or close, remove the dimension from here, 88. Okay. So I just give 88.5 the building height. Okay, 88.5. We also give 90. Okay, no issue. Maximum height is about 88.5. Add, close. In minus x-axis, windward. See, windward face is same, but factor is in negative, -1, and height is about 88.5. Close. In Z positive, wind load. In Z windward face, factor is 1, and the height of the structure is 88.5. Just okay. So last, wind in Z negative, and wind load Z and factor is in negative, -1 and 88.5. Then next we need dead load and live load. So add dead load, DL, add, and live load, change name, live load, double L, title, add, close. Then select the dead load, add about -1 factor for self-weight load, add self-weight load as a -1 factor in y-axis. And the next, member load. Member load means that is -2 kilonewton per meter. -2 Newton in GY. Add. Then we also give plate load here, pressure on full plate. And suppose plate is about 1.150 mm and the material is concrete, so we have to calculate weight into density. Means 150 multiplied by 20. Point 1.15 multiplied by 20. 3 kilonewton minus 3 kilonewton per meter square in
Cannot we do it
GYX.
with the?
Yes.
Cannot we do it with the selecting self-weight on the view?
No, assigned to view. Self-weight we use for the whole structure. We give a self-weight for any type of structure we have. So we give one factor
Cannot
for.
select plate in that.
Huh?
It is not
Weight.
selecting plate. For plate you are giving separately, whereas for beam and columns we are applying this.
No. Say self-weight is assigned to view, and this minus 2 kilonewton load
So
that is
if we are
uniform.
assigning self-weight, if we are assigning to view, it will not cover the plates.
It will cover. Either is there a plate or surface wall. It will assign on all the objects, all the elements.
Then why we are again calculating this plate load?
Oh yeah, because I am calculating a weight, that plate weight. Then next live load, and see for live load we have to give a height range there, because see first 1 to 8 story there is 5 kilonewton live load, then after that 4.5, so we have to calculate and specify this height. So in isometric 32 0 to 32 live load at floor load, that is minus 5 kilonewton in the range of y to 0 is about 30 meter from there. Okay, and
Just 32.
Yeah, 32. Yes, sorry, 32.
Yes.
And in x-axis it's 18 meter and 18 meter in z-axis. And then next we have minus 4.5 meter at the range of at this station. (24 meter). And then next go to general, load and definition again, and in live load select head floor load minus 4.5 kilonewton. Yes, at the range of minimum 32 to 32 plus 24.
Plus 24.
Yes, 32 plus 24. 56.
Yes,
56, and we give the range in x and z axis same as like 18 and 8. Then next 4 kilonewton at the next step. So again I just close this thing and we check the height. And general load and definition, load case, live load. In floor load -4 kilonewton, range of 56 to
20, 76.
70.
76.
Then -3.5. It's 3.5. The range of 76 to 76 plus 12.
88.
8. And we have give the same. Then now we have to give a dead load and live load, assign the dead load and live. So a live load is assigned automatically with the range and self-weight view assigned to view. And for a member load, we select beam. So go to select beam parallel to x-axis, select beam parallel to z-axis, and assign to selected. Then plate load. So I just take a plate cursor and select all the plates, and then assign to selected plate. This load. Okay. Okay. And then for combination, I just click on commands, go to loading, edit auto load rule, select Indian code and create new category, and that is wind load plus dead load. And we have live load also, but I just give only the name wind load plus, and we need 4 loads suppose. Okay, there is all this. Okay, the name is same, so that's why it picks. So I just create a new one again. Wind load on wind load, and number of rule is 4. Okay, wind load is new name. Then first is about 1.5 for dead and 1. Check snow load, check live load. 1.5 for dead and 1.5 for wind load. 1.2 for dead and 1.25 and 1.2 for wind. 9 for update the table, close. Then go to load case detail again, click on add, and see we get these options: auto load combination, select combination code, that is wind load. Indian code, in structure we select wind load. Select load combination as the Indian code and name what we have assigning there, wind load. Click on generate. So according to 4 we get the 13 load combination. Add all this combination here, close. Then analyze, just analyze and print all. Add, this time I need a print suppose, so close, go to analyze, run analyze, then save. maximum displacement. See, we get the results when we during analyzing and print. Now we'll give, we need all information, so we get all this information in result system. And we have options to print out these all sheets. We have total sheet of 249 result. Maximum displacement, see, external and internal joint load summary in kilonewton per meter scale. Their reactions, load reactions. Then next go to post processing, apply. Okay. See, this is the real deflections, and we have summary of maximum deflections in y-axis, that is minus 66.71 for maximum displacement. And for bending, we have these options here, shear force and bending moment in y and z axis both. If you click on bending moment in z axis, we have these bending moments, and for shear force in y axis we have this in z axis, in y axis bending moment, reaction, all the support reaction. Select this cursor, selecting annotate, and move these reactions. These are the support reactions. Okay, with this annotate, selecting cursor, select text cursor, and then we have options to move the reactions. We have different reactions on support. In x-axis, in y-axis, in z-axis, moment in x, moment in y-axis, and moment in z-axis. Is deflection in this building. In plate, go to check the maximum absolute stress, apply then the stress on the plate. Animation, deflection, see, during windy speed about 33 speed, see the deflections we have.
We'll check the maximum deflection permissible itself.
Maximum
permissible deflection. If it is
maximum displacement.
Yes.
Now you get all that maximum displacement readings here in y-axis, z-axis, and maximum relative.
What is the permissible limit? I mean, it will check itself, or we will have to feed it, check it.
No, we have to check it manually. After that, if you want to take a print, so we have this report here. All the reports generated here, see, according to beam property, plate property, sections property, material support, and release, and basic load cases, combinations, load and load generation. If you want to print out these reports, just click on print. So we get all the reports. In these reports, how many pages are there? Around 40 pages are there. 40 pages are there. Now we'll see again the concrete design manual first. It will go to define parameter FC with 25 and FI main, that is 415. and we also use track for result. We need a full detailings, add, close. Then go to command, design beam, add, design column, add, and design slab elements, take off. Close. Select FC 25 assign to view on structure, FY main assign to view, and the track also assigned to view on structure. Then select the design beam. Select design beam, go to select options, beam parallel to x-axis and beam parallel to z-axis. Assign. For element, we select elements with plate and assign. Then for column, select column, go to select and beam parallel to y-axis. Then analyze. Analyze. Save. I think some elements are not designed. That is 55. View output file. Okay, reinforcement percent exceed maximum limit. Their warning is bar size is 16 with the bar number is 18, but percentage is less than 1%, 0.89. .19, bar size 12 and bar number 32 sign 0.83. 2.35, it's exceed this one. 0.98, bar size is 12 and bar number is 20. Concrete design for beam, it will display that concrete design, all the top reinforcement and bottom reinforcement here, and total quantity will display here, the steel quantity weight.
You can show the element design result.
Yeah, we will do element design through British code. I think I didn't get Indian code here for a plate. So I will also show you that thing, slab design also according to that English code. And see, actually, on STAAD Pro now, we're not only analyzing a building structure, we have to analyze a water tank and steel frames like steel tower or industrial roof truss. And bridge design, there is bridge design. So I'm trying to cover, actually we have done most of things in STAAD fundamental about buildings. And now we have to do next is steel designing. Steel like roof truss, steel tower, then water tank, and we have only 3 days left. Wednesday, Thursday, and Friday. No,
Let's go for
foundation will comes in structure and analysis and designing software. There is StatPro is divided in 3 parts. So in StatPro fundamental, we give only the works. How will this StatPro will do works? And there is an advanced StatPro and structure analysis and designing software. So we've divided all the 10 days. These 3 software parts. This software. Advanced analyzing and I will try to cover this thing. But if you have picked that advanced analysis and designing with StatPro, so in that class also it will teach you that things. Same thing. Foundation designing and bridge deck design. And in seismic, there is 2 type of analysis: dynamic analysis and time history analysis. So there is a lot of things in advance. So in fundamental, we have only the simple syllabus to how the StatPro is worked through with a building and with steel structure and with a bridge or with water tank. Sorry. So the next we are going to do this structure, industrial roof truss, and then we do the next steel tower. One steel tower I will try, and the next one you will try, you all. Then next is water tank. Design and analyze water tank. In water tank, we assign hydrostatic load, water load on plate.
Water tank, is it RCC or steel structure?
RCC with RCC. Okay, just leave this one. I will just show you one tower, these things. So you have get the practice for this building session. I will share you that image, and I also share you the one tower. First, I just see we have the time here, so I just show you how to create this tower. See, we have this tower dimension in foot. See, bottom length is 36 feet, so it means our width is also 36 feet, and total height is about 6 into 15 feet, means total height is about 90, and the arm length is 20 feet at both side, left and right side. And see, this is a front view, this is a side view, and we don't have any 3D view. So how will we create in StatPro? Just close and save this project. Control S. Save. Then close. StatPro. Go to new project space. Length units in foot. This time I select foot. Next. Finish. Okay. Edit. I need 36 feet. 36 feet. Only one, and 36 feet in 36. Only one step. But I need in X and Z axis in top view. 1. In Z axis we need 36 feet. Okay. From 0. Then close this. Display dimension. Okay, 36 feet by 36 feet, and remove dimension. Remove, close. Now see, we have to create one cone. That cone height is about 90 feet. So how will we do? I just take a beam and just join cross section, and then I select both beam, the center beam, and go to geometry and intersection selected member, intersect. Okay, then see, I just select this node, this center node, and go to geometry and select move from joint, and height I give just 90 feet in y axis. Okay, yes, see, select beam cursor, select all these 4 beam and remove bottom beam. Then now see how many nodes are there in beam. 1, 2, 3, 4, 5 nodes. So select all this beam, go to geometry, insert node, add number of point, we need 5. Okay, done. Now we have to add this nodes with beam manually, or we have options. Suppose if I select node cursor, go to front view, and I select this all nodes and go to geometry, connect beam along x-axis 10 beam, and geometry connect beam along, where it is, connect beam along z-axis. Okay. Then next we have to connect as a cross section, like this. Cross section. It's a manual work in history. Then just rotate with arrow key and connect this side. Rotate again. Now next this 20 feet arm at both side, left and right side. So go to front view there and select this side node. Go to translation repeat, click on translation repeat. In x-axis we need -20, because see, this side x-axis is positive, so it back side we give the negative value of -20 feet. Then no need to link. Then select this side node, translation repeat. In z-axis this time positive in 20 feet. Go to isometric view, select beam and join this. And then next we have to select these 2 beams and insert node at midpoint. Insert node at midpoint. Okay, then select the beam and connect with this. select beam cursor. Okay, go to front view again, and yeah, we need a midpoint. So select beam cursor and select all this. Isometric, geometry, insert node at midpoint. Select beam cursor, join. See, from front view, side view, front view, side view. And see, for a steel structure, we use property. In general, we use this option, section property, not define. Okay, just go with section property for steel. For plate thickness, this one, define column beam. For concrete or steel, this one. For angle or I shape, W shape, S shape, steel, go to section database. See, when I click on section database, so we get one tab here, one new tab, this type. And see, we have all the steel type here, American steel, and we have Indian steel. According with Indian steel, we have a Jindal steel and a Tata steel also. See, in Jindal steel, we have UV shape, UC shape, IP shape, HE shape, these all the shapes, and Tata structures, we have these four steels there: rectangular hollow, square hollow, and circular hollow steel. We use this Tata steel and Jindal steel to create sheds, bus stand shed or stadium shed. This time we use Indian S shape, I shape, M shape, W shape, T shape, all this. Suppose for steel tower we use angle shape. So when you select angle, so we get all the shapes here, all the size, their length, width, and their thickness. ISA. If you click on this view table, so you can view that their depth, width, and thickness also. So suppose if I want to use this section, 200 mm depth and 200 mm width and 24 thickness, select this one. Again, click on this same again, then add, then close. See, we get this steel. Just select it and assign to view for whole structure. Then go to 3D view. See, my steel angle. Will assign steel angle as on this tower. Then next for support, I have to change for support and load definition. Now we have to change the unit because load will calculate in meter. So we just change the unit. So we have these options here: input unit. Click on input unit and change from foot to meter. Click on meter. Okay. Then go to support. Create support. Add. Select this fixed support. Go to front view. Select all the nodes and assign to view on these four nodes. Hit down. And for loading, see, go to load and definition and assign wind load on this tower. Wind load, wind definition, add. Select wind load definition, add. Calculate as per. second category, suppose 33 meter per second exposure, we give open field RC, and this time we have truss tower. Apply, okay. Add exposure 1 and close. Select assign to view exposure. Then go to load case, and again we have to add a 4 side wind load. In X positive side, control V in X in negative side, and control V in positive Z side, control V Z negative side, and close. Wind load. So X-axis 1 and the height. Tower height, we have to calculate tower height. It's 90 feet. So in meter, its height is about 27.4. So we give here 27.5. 27.5. 27.5 and length on front view. 15.85 in X-axis. So we give we give around 15 point something. So we give 16 or 20 in X-axis. So it will cover the wind pressure on that's in X-axis. And in Z-axis, it's 36 feet length. 36 feet length, so it means we have to give 11 meter at this side. 20, 11, 27.5, add close. In minus X-axis, add wind load, -1 factor, 20 and 11, Z-axis. In positive Z and wind load in Z on 27.5, 11, maximum, sorry, 20 and 11 inch. -1 and 27.5 to 11. In load case detail, we had only dead load here. Dead load DL, DL add, and in dead load we assign only self-weight. Add, select self-weight, add, close. Select self-weight, assign to view. Then analyze and print, add, close, analyze, run, analyze, and see. Go to post processing. See the maximum displacement here, we have -0.764 in y-axis. The maximum sorry, displacement. Reactions on all the 4 These are the reactions on support. Okay, see the reactions, support reactions, and in animation we'll see that deflections. See there is a little bit deflection here. So this is a method to design, creating the steel structure, and for property we use section database and support, and then in load we assign wind load on this tower, seismic also if you want to assign seismic load on this tower. So you have two topics to practice. First one is a building, and second this tower, this one, and this length are in meters. All the dimensions are in meter.
Sir,
Total height is.
should I consider the wind load for wire?
Wire?
Wire connected the ropes connected
Yes.
to towers.
Yes.
And this is not is considered here.
Which one?
Wind pressure in ropes between two towers.
Between two towers.
Yeah. Between the towers, there should be between the towers. They are the connected by the wires.
Yes.
And there should be a wind pressure on that wire.
That wire, yes. Okay, so we'll do these things, and we'll also have to do a industrial roof truss. So you have to practice on first a building and then on this top. Just try to create this structure and assign section property and assign wind load and dead load on this structure. अबे यार अरे चुप करो
ऐसे निकाल लो ऐसे आपने नहीं ना
Okay, so you just practice on this topic, and tomorrow I'll come with a new topic. Okay. Hello.
Sir,
Yes.
sir, I have a doubt to how to create plate. Actually, in this Connect version, you are command that is plate grid, I think.
Fill. Okay.